Imagine modern digital work as an endless stream of identical file folders moving flawlessly down a mechanical assembly line. On the surface, every item looks exactly the same. Across healthcare, insurance, and enterprise operations, organizations measure employee productivity based on this exact illusion. The primary metric for success is almost always a single surface-level number, the volume of documents processed. A digital document functions as an operational container. Inside each container lies a nested, highly variable web of specific tasks, subtasks, and decision points. One container might hold a simple request requiring 3 basic verification steps that take exactly 2 minutes. The next container in the same queue might demand deep medical research, 5 external database lookups, multiple correspondence letters, and a supervisor's approval. This infographic outlines what happens when a productivity system counts both of those containers equally. The organization develops an invisible blind spot. As a direct consequence, managers receive distorted operational data, and leaders begin optimizing the wrong processes based on faulty assumptions. This systemic failure mathematically penalizes the hardest working employees handling complex cases, while artificially inflating the performance scores of those pulling the simplest tasks. This data table highlights a real-world scenario. Look at the raw output. Employee A processed 18 documents today. Employee B processed 9. Traditional reporting draws an immediate, unnuanced conclusion. Employee A is highly productive, and Employee B is failing. To find the truth, we have to look past the surface output and measure the hidden mass of work actually performed inside those operational containers. This requires a different metric, complexity units. Instead of rewarding raw volume, this unit measures true operational contribution by assigning weight to the difficulty and density of the tasks completed. When we evaluate that same workload by complexity, Employee A's 18 simple documents generate an operational score of 31 units. Employee B's 9 documents, however, required extensive research and clinical review, generating a true operational score of 52 units. Employee B completed significantly more actual work for the organization, yet on standard enterprise software, their performance appears drastically lower. Failing to track complexity creates a professional misconception. It discourages top performers, drives workforce burnout, and ultimately pushes your most capable employees out the door. Let's open the black box of Employee B's workload and examine just one supposedly simple document, a standard massage therapy claim. The intake phase alone requires the processor to navigate separate EDI gateways and mailroom systems just to associate the claim with the correct membership databases. Next comes the provider verification burden. The employee queries external databases to check the provider's licensing, their NPI number, their taxonomy codes, and their federal compliance status. Then they perform clinical coding validation. The processor cross-references the patient's ICD-10 diagnoses against specific therapy modifiers and CPT procedure rules to evaluate medical necessity. Before closure, the claim requires financial calculations. The processor applies contractual discounts, deductibles, coinsurance, and coordinates secondary payer rules. This breakdown reveals the total labor for one claim: 48 tasks, 97 subtasks, and 19 decision points. Notice the bottom row. Manually switching between 12 disconnected systems creates a high cognitive load and severe error risk. Treating this massive web of fragmented logic as one document processed is a cataclysmic failure of enterprise measurement. Organizations correct this by engineering systemic architecture that captures and credits hidden labor automatically. This is achieved through the CLADS framework, Comprehensive Logistics for Automated Decision Support. It acts as a unifier, pulling fragmented systems into a single intelligent interface. CLADS automatically generates an electronic claim profile before work begins. The system pre-scans required tasks, identifying the complexity level and estimated processing time. This forecast converts into a standardized overall work weight, establishing a baseline for productivity scoring. By presenting a consolidated view, this role-based interface removes the need for manual navigation. The processor focuses entirely on operational judgment rather than wrestling with software. Shifting from passive document counting to active task intelligence aligns enterprise KPIs directly with actual human effort. This Audit tab overlay demonstrates how post-work auditing evolves from a hidden management spreadsheet into a transparent feature of the workflow itself, tracking every completed task and subtask. Here, the system clearly explains that processing 8 documents actually required completing 296 separate tasks. It automatically credits labor that typically goes uncounted, logging minutes spent on manual research and interruptions. There are no hidden formulas, just complete transparency. Making operational effort visible builds deep trust between staff and management, and provides leadership with the exact data needed for accurate workload balancing and staffing forecasts. Task Intelligence goes beyond fair labor reporting. It delivers immediate financial and operational benefits. Process quality cannot rely solely on human memory. As shown in this list, the workflow architecture enforces accuracy by performing real-time CPT and duplicate claim validation. This systematically removes opportunities for human error before a decision is finalized, while preserving necessary employee oversight. For the enterprise, this specific accuracy translates directly to lower administrative rework costs, fewer payment denials, and sharply reduced compliance penalties. Furthermore, having granular data on every subtask allows organizations to pinpoint exactly which repetitive actions are the best targets for future AI automation. By engineering procedural integrity directly into the system, Task Intelligence functions as an active, real-time quality assurance engine. Ultimately, this approach applies operational bioethics as practical engineering constraints for enterprise software design. This illustration visualizes justice in operational design, ensuring performance evaluations and workload distribution reflect the true balanced substance of the work, rather than a superficial document count. It enforces non-maleficence, the principle of doing no harm. Poorly designed metrics actively harm employees, inducing chronic stress and forcing rushed shortcuts just to hit unrealistic volume targets. A safer workflow protects workers by setting realistic expectations grounded in transparent, data-driven measures of complexity. It achieves beneficence. It extends beyond avoiding harm, creating systems that actively empower workers with real-time insights, clear guidance, and explicit recognition for their effort. This graphic outlines the ultimate vision of modern document processing. Built on pillars of procedural integrity, transparency, complexity awareness, and bioethics, organizations can move permanently from counting shallow activity to measuring meaningful operational contribution. Aligning enterprise technology with human dignity creates a fairer workplace and establishes the foundation for long-term operational excellence and sustainable financial stewardship.